This video discusses the concept of leakage. Suppose that we have the following situation. We have a person who is managing a project, and on this project, there are a bunch of trees, and their job is to protect the trees. This is the same example that you've been using for the other videos as well. And in fact, they do protect these trees. So instead of chopping this tree down, what they do is they go to a tree that's just nearby and they chop that down. If you do this, the project over here still has the same number of trees, the same amount of carbon sequestration, but overall the climate suffers because instead of having this tree down, we have this other tree down, and this is what's called leakage. So if there is leakage, there is really no climate benefit. What's happening is that the person gets the payment for protecting the forest, but then they are just displacing their activities to a nearby location, and the climate suffers due to the carbon dioxide release after the removal of this tree over here. So how can we identify and prevent leakage? The short answer is that it's really hard to do. And one way of doing is like this. We can look at the following. So let's say this is the project area. We can create a buffer zone around it. And when we look at the pixels in the project as we do normally, we'll also look for pixels in the buffer area. And if we find that the project is okay, but the forested pixel in the buffer has been deforested, then we can say that this is an example of leakage. And importantly, this can be done from space because we can just look for all the pixels in the leakage buffer and see whether there has been deforestation in the buffer zone, even if there has been no deforestation in the project zone. So that's the approach we take. But of course, you might ask this question, how big should this buffer be? Or should it be 2 kilometers, 5 kilometers, 10 kilometers? It's very hard to answer that. And we really don't know exactly what is going to make sense. And so this is still an open area for research. The other problem is that any buffer that is local may be insufficient. So let's say that the person over here is going to chop down trees normally and sell them at some market. And if they protect the forest, they don't have any more supply of trees. But the person who's purchasing it from the market may decide to buy from the different part of the world. So instead of buying it from, if this is the world and the part of the world they're buying it was from here, they might just decide to buy from the other part of the world over here and just ship it all the way to them. And so this way we have what's called global leakage, in the sense that we are replacing wood from a local country from wood being grown elsewhere. And then of course you have the same exact problem, which is that this trees that have been cut down in that remote location are going to then emit CO2, and we really haven't solved the problem at all. Again, this is a problem where considerable research is being done, and at the moment we don't have a fully defined solution, but this is something that we are working on in our research at the 4C Center.